Okay, I can't even believe I'm going to waste time teaching this. It's going to sound like I'm really insulting your intelligence, but I'll do it. Now it says make a diagram lists what's called the sample space for the event. Now, if I roll 3 dimes, a dime can have heads or tails. Okay, so I can roll heads or tails on the first row. But then on the second row, well, maybe there's tails, but maybe there's another heads, okay? And then on the third row, maybe it's tails, maybe it's another heads, okay? Or maybe it's heads, heads, tails, okay? Now if you do a tails, maybe you get all 3 tails, okay? Maybe you get tails and then a tails and then a head. A tails, a head, and then a tails, okay? Maybe a tails, head, and a head. And, let's see, there's one I forgot. I know I did. Oh yeah, heads, tails, heads. Okay, I think that's all the possibilities. Well, there's 8 possibilities that could happen here. But rather than screw around and do that and list out everything that could happen, there's a much easier way. When you roll a dime, there's 2 possibilities, okay? But we're rolling 3 of them, so therefore it's 2 to the 3rd power, which is 8, okay? That's an easy way, okay? There's 2 possibilities and how many times you're doing it, so to the 3rd power. Okay, another one, flipping a coin with one hand and rolling a dice with another. So I'm rolling 1 coin, and that has 2 possibilities, heads or tails. A coin has 2 sides. Then I'm rolling a dice. Well, a dice has 6 sides, so there's 6 possibilities. So 2 times 6 is 12. Okay, spinning of 2 spinners. Okay, so how many? Well, there's 2 possibilities there. Then there's 3 possibilities there. So 2 times 3 is 6 possibilities. Okay, I'm going to make up another one. I'm going to put rolling 3 dice. Okay, so the first dice has 6 sides. Don't worry about that power crap like I did on the first page. Roll 1, and then I roll a second dice. That would have 6 sides, and a third dice would have 6 sides. So 6 times 6 times 6, that's 216 possibilities. Okay, you just got to think a little bit. Okay, now this is pretty easy. Menu offers 3 types of desserts, 4 different entrees, and 3 desserts. How many different meals could be ordered, okay? Well, I order 1 dessert. There's 3 of those I can get. Order 1 entree, but there's 4 possibilities. And I order 1 dessert. There's, wait a second, that doesn't make any sense. I should say 3 sides, okay? You can order 1 side. There's 3 possibilities. So 3 times 4 times 3 is 36. Okay, how many different outfits? If you can only wear 1 shirt, but you got 5 possibilities. You can wear 1 tie. There's 4 of those possibilities, and 1 pair of pants. 3 possibilities. 5 times 4 times 3 is 60. Okay, so that's 60 possibilities you can do. Okay, go do these problems. You should fly right through them. Okay, pause the video. Flipping 2 quarters. Remember, 2 sides. 2 times 2. 2 dice. There's 6 sides, so it's 6 times 6. 2 of them because you're doing it twice. Okay, now you're going to do probability next, okay? Probability is used to make educated guesses about the likelihood of events. For probability of a chance, an event, and outcome occurring is a ratio, but we're going to actually make it into a percentage. Okay, probability is always involved uncertainty. It might happen, there's a little chance, even if it's a small chance, but then there's a probability it might not happen, okay? And you did it in biology with the genetic tables, okay? Weather, percent chance of survival. It's like a scientific law. If you run enough trials, it always evens out. If you were to sit all day for 5 hours and flip a coin just endlessly, it would come out 50-50, okay? Guaranteed. If you did it enough times, it would, okay? Guaranteed. Okay, now we have the following marbles, okay? The following marbles, if you put them on a bag, find the probability of the following picks. So I've got S is silver, Y is yellow, yellow, silver, green, silver, silver, green, green, and then purple, okay? We're going to put them all in a bag and find the probability of the following picks. So I make a ratio, and how many marbles are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? There's 10. Okay, how many of those marbles are green? So 1, 2, 3. 3 over 10. Now I want that in percent for them. Some of you know it's 30 right away, but if you don't, you divide it. And then you can either move the decimal twice to the right with your hand, so 30, or you can just times it by 100. It's the same thing. So 30%. If you put 0.3%, it's wrong. That's ridiculous. Okay. All right, silver. There's 10 to pick from. How many are silver? 1, 2, 3, 4. There's 4. Okay. So that's probably going to be 4 divided by 10 times 100. It's 40. I'm just showing some of you who aren't very good at that. 4 divided by 10, and then that has to be multiplied by 100. So 40% chance you get a silver. 60% chance you wouldn't. The percents always add up to 100. Okay, yellow. There's 1, 2. Okay, so 2. So I take 2 divided by 10 times 100 is 20%. Again, this seems really elementary to almost all of you, I know. Okay, purple, there's 10, and there's 1. Okay, P means probability. Okay, that's what that stands for. 1 divided by 10. Oops. 0.1 times 100 is 10%. Okay, probability of not green. Okay, so I add up I count the ones that aren't green. 1, 2, 3, 4, 5, 6, 7. So it's 70%. Okay, now a lot of this has to do with cards, and here's a card sheet you have. You got hearts and diamonds. There's 13 of each one. Now those are red cards. There's 26 red cards altogether. And then black is clubs and spades. There's 13 of those altogether, and we got 26. Okay. All right, now there's 52 cards in a deck. So every time I pick a card from a deck, there's 52 possibilities. Okay. Possibility of a 2 of diamonds. Well, there's only 1 2 under diamonds, so that's 1, okay? So the odds are pretty small. 1 divided by 52, and then times 100. Round your percent to the nearest tenth, so 1.9%. Okay, probability of a black 3. Well, here are my black cards, and there's this 3 and this 3, so that's 2 of them, okay? So 2 divided by 52 times 100, and that's going to be 3.88%. Okay, probability of not a spade. Now, I don't want a spade, so there's 52 cards in a deck, okay, and I count how many spades there are. Well, there's 13, so I don't want to draw a spade, so I subtract 13, and that's 39. Okay, those are going to be pretty good odds. 39 divided by 52 times 100 is 75, so 75%. Okay, probability of a black jack. So here are my black cards. There's a jack here, that's 2. So I take 2 divided by 52 and multiplied by 100 is 3.8. Yeah, it'd be the same as up there. Okay, you're going to come across this term, a face card. Face card is a jack, a king, or a queen. Doesn't say what suit, doesn't say what color, so I just count the jack, queens, and kings. All those have faces on them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 of them. Oh, it has to be a red. I'm sorry. I screwed that up. Okay. So red, I don't count the black ones. 1, 2, 3, 4, 5, 6. So 6. So I take 6 divided by 52, multiply it by 100, and that's 11.5% chance. Okay, you can pause the video. There's one problem that you got that's kind of screwed up. Okay, so that says not blue down there. Okay, problem is with the B's, you don't know what's blue and black. Cross out black. Don't do that problem. There are no black marbles, okay? Because with the B's, you don't know blue and black. So just do these 4. It's quick. Okay, here's my next one. Independent events. When you roll a dice, the second roll is not affected by the first. What that means is if you roll a 3 on the first, the dice is still going to have, on the second roll, the dice has the same number of possibilities, okay? So this time I want to find the probability if I roll 2 2s in a row. So this time there's 2 events instead of just 1, so I make 2 ratios. Now, when you're rolling a dice, it's smart to write the numbers. I know that seems kind of stupid, but it helps, okay? Okay, so I've got 6 possibilities on each roll. There's only 1 2. You don't put 2, okay? There's only 1 2, and there's only 1 2. So what I do is I multiply those. So 1 times 1 is 1, and 6 times 6 is 36. Then I take 1 divided by 36 and times it by 100. So 2.8% chance you get back-to-back 6s. Not very likely. The likelihood that you wouldn't is like 97.2%. Okay. Probability of a 4. Well, there's only 1 4, and then the 5, there's only 1 5. Okay. So that's, again, 1 over 36, and we know from the past that that's 2.8%. Okay, probability of a 5. I'm always using 6 on the bottom. Probability of a 5, there's only 1 5, and then an even number. So how many of these numbers are even? 1, 2, 3. So 1 times 3 is 3. 6 times 6 is 36. So I take 3 divided by 36 times 100, and that's 8.3%. Okay, this says probability of an odd and anything but a 3. Okay, so I put not 3. So 6 and 6. So how many odds we got? 1, 2, 3. Okay, how many numbers do we have that are not 3? 1, 2, 3, 4, 5. You just got to think about it. So that's 15 over 36. So 15 divided by 36 times 100 is 41.7%. Okay. All right, now let's go back to our card sheet because now we're going to draw from a deck of cards twice. Now, we will be putting the first card back because it says after you draw the first card, you put it back. So that means on each draw, there's 52. Okay, red. How many red cards we got? Well, 13 and 13, that's 26. And then a spade. Well, here's spades. There's 13 of them. Okay, so I take 26 times 13 is 338. And then I'm going to take 52 times 52, and that's 2,704. And then I divide and times that by 100. So it's a 12.5% chance. Again, I want it as a percent. Okay, 52 and 52. So I want to draw a king. There's 1, 2, 3, 4. Doesn't say what color, doesn't say what suit, so I just count them all. And then another king would be 4. Okay, so we know that this bottom's always 2704. 4 times 4 is 16. Okay, so I take 16 divided by 2704 and times 100. So that's 0.6. It's less than a 1% chance. If you end up with a decimal with 0 point, that's fine. Okay, 52, 52. So I want to draw a jack of spades. So it's spades and then the jack. There's 1 ace of diamonds. So diamonds, and here's the ace. There's only 1. Okay, so 1 times 1 is 1. 52 times 52 is 2704. So I take 1 divided by 2704 times 100. 0 point, okay, you can't go to the nearest tenth. You got to go to the nearest hundredth now because you don't want nothing but zeros. 0.04%. Okay, red, okay. And no, it's not half. Yeah, once would be half, but doing it 2 times in a row, no. Okay, so red, okay. So I've got 13 and 13, so 26 and 26. Instead of 50%, it's actually going to be 25. It's half that. 20. So you get 676 over 2704. 676 divided by 2704 times 100, and that's 25. So that's 25% chance. Okay, probability of a red face card and then just a face card. So here's my red. So 52, 52. So 1, 2, 3, 4, 5, 6. And then just a face card. Could be any color because it doesn't say the color. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, 6 times 12 is 72. And then 52 times 52 is 2704. So I take 72 divided by 2704, times that by 100. I get 2.7%. Okay, now pause the video and go do 1, 2, 3, 4, 5, 6.